So hi, I'm Brendan Shanks, work at Cross Codeweavers, mostly on Mac and on Crossover. So I gave a similar talk to this at the last WineConf 3 years ago, um, going over some of the issues we've had on macOS side. And there's been developments in the past 3 years. Thought I'd start with kind of the most high-profile development. That was Apple's game porting toolkit. It was kind of an umbrella term for kind of a grab bag of projects. There's the metal shader converter, there's sample code, their metal C++ wrappers go in there, and then the evaluation environment, which is what we're interested in. So what is that? The stated goal was to allow Windows developer to evaluate their game on the Mac without having to change it at all. And despite going through several translation layers, CPU graphics, and wine, just kind of see what's possible. And so at least in the first release, what that consisted of, there's homebrew recipes to automate building crossover 22's wine. That was 7.7. And then some patches added to enable syscall emulation. There's a workaround for the GS conflict, and then various patches from Proton, mostly Media Foundation, just to enhance compatibility. And then there was D3D Metal, which is D311 and 12 to Metal translation layer. Like I said, that was the first release. Later on, especially certainly this year, they stopped including the homebrew recipes. I think just because it's very difficult to keep building such an old wine with modern tool chains. That also included our hybrid compiler at the time before WoW64 was working, so it's trying to build that from scratch is kind of a mess, and it doesn't work with Steam, and there's binary options. That's really sending people in the documentation. So anyway, mentioning D3D Metal, I thought I would talk about some of the graphics options that we have now. So D3D Metal, it's a closed source D311, 12 Metal to 11, 12 to Metal translation layer. They have continued to improve it over the years. Every year there's sort of a major version. V2 brought DirectX ray tracing. V3 this year added DLSS upscaling, denoising, frame generation using Metal FX. And there's been plenty of bug fixes and compatibility improvements. Another new option we have last year is DXMT. It's an open source D310 and 11 to Metal layer by Feifan, who's here. And then Molten BK is also an option. It's now Vulkan 1.3 compliant, and in combination with improvements to WineD3 and VKD3 has much improved compatibility. It's also the only option that's compatible with Intel Macs, which are getting older now, but still in use. So I mentioned the syscall emulation that was added. So this is some background. Some 64-bit Windows apps use the syscall instruction directly. It's often for anti-cheat or DRM schemes. That way they bypass any hooks that are in kernel 32 or NTDLL. On the Mac, the syscall numbers all have a high bit set, so they don't conflict with the Windows ones, which go from 0 up to 2 or 300. So if you do a Windows syscall on the Mac, you get a SIG-sys signal. This didn't previously work on macOS. There was a kernel bug. They fixed that in macOS 14, so it started working at that point. And then the game porting toolkit had a line patch to handle SIG-sys and be able to handle that syscall. And since then, I've merged that upstream in Wine. And it works on Intel and ARM16. I also mentioned the GS conflict. I talked about this 3 years ago, so I'll give a bit of a recap. 64-bit Intel Macs and Windows Both use the GS segment to point to thread-specific data in the Windows tab, TSD. Since Wine did not have a hard boundary between Unix and Windows code, they had to share one, which was the Mac one. Apple reserved a couple slots for us, which allowed most Windows apps to run. In addition, with some extra hacks like patching binaries, Windows binaries as we load them, some macOS libraries being patched as well. But there were still some apps that did not run, including some anti-cheat schemes. So in macOS 14, Rosetta gained the ability to redirect direct GS accesses by code that's in a specific code range through the self to essentially sort of work around this problem. And the game point toolkit included a wine patch so that as PE binaries are loaded, the full range of that binary gets added to this list. So any GS accesses by PE binaries sort of works correctly and is accessing the tab in the window TSD. This works quite well, and it is compatible with a lot of games. But there are some downsides. It doesn't work on Intel Macs because there's no Rosetta there, or older versions of macOS on ARM64. Also, D3D Metal has some distribution restrictions around it. It's limited to non-commercial projects. And the way that we call into Rosetta is through a library included with D3D Metal. So there's situations where it can't be used, not suitable for streaming. So can we improve the situation when you can't use this Rosetta redirection? I said earlier that Wine did not have a hard boundary between PE and Unix code, but Wine now does have a hard boundary between PE and Windows code. So we can set GS space to the Windows tab when we jump to Windows code and set it back when we need to run Unix code. I worked on this over the last year, so it's been upstream in Wine since April. There are some downsides, though. In particular, there's no public API to set GS space on Mac, so we're using a private API. That is a kernel syscall, so there's some performance overhead. If you're doing a Unix call or a syscall, there's going to be, you have to do that twice. You have to set it to Unix, set it back. I haven't seen that it's a noticeable performance impact in the games, although we need to do some more testing on that. Also, there's D3D Metal kind of assumes that D3D Metal jumps directly from PE code into Unix code, sort of for performance reasons and kind of because of how it's architected. This used to work because GS was the same in both cases, but now that no longer is, that doesn't. So upstream Wine is not compatible with D3D Metal. With crossover, because we do support D3D Metal, my plan that I haven't quite gotten to yet is crossover will use the Rosetta GS redirection when it's available, and when it's not, we will set GS space. So I mentioned Rosetta a few times. Rosetta is the system level translator emulator on ARM64 Macs to run 64-bit Intel Mac binaries. And if they set up 32-bit code segments, it can run those as well. And it emulates the whole process, generally transparently. There's been some improvements. macOS 14 added EVX and EVX2 support. Although if you need it to show up in CPU ID, you have to set an environment variable. And then this year, macOS 15.4 added the bit manipulation instructions and F16C. Those were all for game compatibility. Increasing number of games need AVX, and the BMI and F16C as well. Otherwise, there's been a lot of bug fixes, but not any other major changes. I mentioned some of the issues a few years ago that are still present. x87 floating point performance is, I think it's improved, but it is still pretty slow. There's no exceptions from x87. Cross-process code modification doesn't get detected. You kind of have to hack around that. No cross-process register state. The debug registers are not implemented. And then we have really no logging ability with Rosetta, ability to debug it. You can attach to translated processes, but it does not work particularly well. There was an announcement this summer about Rosetta. I'll just put up the statement that Apple posted. In a nutshell, presumably there will be a macOS 28 coming out in about 2 years. It is going to only have a subset of Rosetta functionality aimed at supporting older unmaintained gaming titles. I'm sort of choosing my words carefully. We have some confidence that the set of older unmaintained gaming titles will include Wine. And I don't think I have too much more to say on that.
We're quite happy to see the progress of Flex and Box 64.
Yes, we are. So regardless, that's not an ideal situation to be in. So how's ARM64 Wine? 3 years ago, I kind of listed the known issues. Unfortunately, I don't have really much to report. The issues we know about, the x18 register, Windows uses it for the tab. macOS reserves it, and the kernel is kind of able to clear it at any point. In addition, page 0 needs to be at least 4 gigs, so that prevents mapping user shared data in the correct spot. Would obviously be a problem if you wanted to emulate 32-bit code. I've been working with Apple on these issues, so I'm optimistic we'll have some progress soon. The other issues, 16K pages. I think Alexander's done some work on that this year, and it's kind of increasingly an issue on Linux as well. And then pages that are both writable and executable are not supported. I don't think there's too much of that left, any of that left in Wine. It can maybe be kind of emulated if you flip it. So talk about something also kind of low level. So the preloader that Wine uses on Linux, FreeBSD, uses a statically linked binary called the preloader to reserve memory ranges with C runs. We used to use this on macOS, but statically linked binaries are no longer supported. It's been increasingly problematic over the last couple of years. We had to pretend we were building for a really old OS to even build the preloader. Everything about it was deprecated, kind of private APIs. And in the past couple of releases, we found that it wasn't even running first. Rosetta would reserve memory earlier, so would libsystem. So since last summer, Mac, we now use a zero fill section in the Wine binary to block out the entire low 8 gigs of the address space. This is the entire 32 gig space, 32 bit space, which we need to run WoW64 binaries, 32 bit binaries in WoW64. And then also everywhere where we've seen 64-bit exes be based, in theory, there could be a 64-bit exe that's based, right at the 8 gig line. That would not load. But We haven't seen it. If we do, we might need to bump it. So far, this has been working really well. It does require Xcode 15.3 to build. Apple had to add a linker flag to be able to build this. That came out about 1.5 years ago. If you build with something older, you will get the preloader instead. And also, if you are still building for 32-bit macOS, which is increasingly kind of history, but we're still using the preloader there. There's been some new options in terms of synchronization as well. I know that can often be a performance bottleneck for games, especially with a lot of high thread counts. We have eSync available on the Mac. Another recent one is MSync. It's a patch set by Mark Rell, who's here. Uses Mark semaphores and futexes. It also kind of suffers from the same correctness drawbacks as eSync, so it's also arbitrary. Anti-sync is exciting. We like to explore that on the Mac, I think. Although there's difficulties there. Kernel extensions are deprecated, still exist on Intel and ARM, but they are kind of painful for users to install. But it would be interesting to try it as a kernel extension and at least to see what's possible.
I had essentially written one, and we never.
Yeah, I experimented with that too. Yeah, we can. It would be very interesting to try it out. Sort of a higher level macOS feature that has caused some trouble is something called cooperative app activation. This is a feature in macOS 14. The goal there was to prevent apps from basically stealing the foreground focus from each other, which I think is noble. It causes some trouble with Wine because we launch new processes and then want them to be in the foreground. Tim added support to Wine upstream that enables Wine processes to be able to steal focus from each other. So if you're running Explorer and you launch an exe, it will come to the foreground like you expect. The case where this is annoying that we can't really do anything is that if you launch Wine from the command line, whatever you launch ends up in the background, Wine boot or whatever, and you have to go like in the dock to bring it to the foreground. So you run it and you don't even realize it's there, and then you see it in the dock. You think it's broken. So yeah, and then a couple of other features that I'm sort of hoping would be nice to have on the Mac that we can do soon. Display mode emulation would be great. The idea here is that if Windows games change the display mode, rather than changing the actual mode of the display system-wide, you just sort of emulate it, scale up the output, flip the cursor. This is great because on the Mac, changing display mode, it's not deprecated, but it's definitely not recommended. Games don't do it anymore, and causes various bugs. In addition, on recent Macs, Apple Silicon Macs, they're missing common PC display modes. And especially older PC games often expect these to exist and don't handle it well if they're missing, crashing or kind of breaking. Rami did a lot of great work on this over the last year, and it's mostly working on the Mac right now as well. Some bugs around things like cursor flipping. Ideally, we would basically just use that only and take out support for changing the mode. And then also high DPI is something that would be great. Macs have shipped with Retina displays for more than a few years. Right now on Wine, we are basically always telling Windows apps that it's just a 96 DPI screen and then scaling everything up. again, Remy's done a lot of work on this in the past year. So we have DPI virtualization now, so that apps that don't support this will get scaled by Wine itself. The kind of biggest blocker on this on the Mac side is that our GDI drawing performance is quite slow. We're kind of using the wrong APIs so that color space conversion is happening on the CPU rather than GPU. And if you open a large wine window on Notepad or something, you can kind of see it lagging, especially if you move around the mouse on the menu bar. But we've been working on using IO services instead, which is much faster, I think. Hopefully once that's done, then IDPI will be more feasible. So that's all I have. Questions? Yeah. Can they detect 16K pages and fail to run? So I think we're always going to tell Windows apps that they have 4K pages.
Yes.
I think there's definitely cases where we won't be able to work around the lack of 4K pages. We're hoping that's not common. If a Windows app wants to set different protections on adjoining 4K pages, it's going to be difficult to maintain those guarantees. But yes.
Maybe two questions. First, the smaller one. You complain about the X18 register, and I know that very well because, yeah, R64 first patches already hit that issue more or less. But the new RAW 64 is basically the barrier between E and Windows and really works around the issue. So I wonder why you're still complaining.
So what Apple's told us is that the kernel is prone to clearing X18 at any point, like on context switch into the kernel or anything. Yeah, not just so yeah, it could be zeroed out.
I was aware of that. The other question would be about the display mode. As far as I know, isn't there a Proton patch set that enables this scaling thingy you talked about? And would it be a possibility to upstream it?
So I think that's actually mostly upstream now. You can run the Wine display settings control panel, and there's a checkbox to enable interlighting display modes. So you can do that now, and I think there's maybe still some bugs. I know that I think that was Remy upstream that to be used in Proton and replace their previous.
All right, thanks.
Yeah.
Yeah, I have two questions. I think my first one is, do you know if the exact mechanism D3D method was using to talk to Rosetta to enable the GS-based emulation? Like, is it an undocumented instruction calibrated?
Yeah, so it's there's basically a private. I don't remember if it's a magic syscall or something that the library does just to basically call into those or if the deal opens or something. But yeah, I mean you can disassemble it and see.
My second one was, I know some games, I think maybe some of the modern Halo games, they take advantage of like place memory map. No, place memory map. So some of the new virtual memory APIs in Windows allow for remapping pages on a rather than like the standard 64 byte element, 64-bit byte element on most APIs. Do you have any ideas about how you go about emulating that with 16K pages?
I don't know. No, I hadn't. I wasn't aware of that. That would make things more difficult. Yeah. Yeah, I know that Rosetta has support. Like obviously inside of Rosetta, you have 4K pages. there's a bunch of code, I think, in the kernel to basically make that work. But it's not available to anything else above the kernel.
I suppose, would it likely be that, say, even if wine did show that instance, kind of thing that
Right, yeah, and it's you would have to be, it would probably end up being like sort of process wide, and then the problem is that none of the other libraries in the process would be expecting to have 16K pages on it. Or 4K pages in an ARM process. Anything else? All right, thank you.
Guess you're off the hook. Thanks very much.